All right, next up is our topic of titration. So you've probably done titrations. The point of a titration is to find an unknown concentration by using a known concentration. So you probably did a titration back in Chem 101. We'll do one in this course as well. And so in our case, with acids and bases, the concentrations that we're talking about is the concentration of H plus and hydroxide. But you can do titrations for other stuff as well. And so there's something called the equivalence point. And so this is when the concentration of H plus is equal to that of the hydroxide, which is generally your endpoint of your titration, but not always. And so here's basically how a titration goes. In general, we have the base up top and the acid in the bottom. And so we have an unknown concentration. We don't know how acidic this is, but we know how basic this solution is, right? So we know one, but we don't know the other. And so we start titrating, we start mixing them and recording how much of the base we used. Eventually, there's a color change that indicates that the titration is done. And so you know the concentration and the amount of your known that you used. And so you can calculate what the pH or the concentration of H plus is in your unknown. So just to give you kind of a look at this, right? So like pH would be somewhere around here. So 7, 0, and then 14. In this case, we'd start off kind of close to 0, a strong acid, and then it would kind of just shoot up and then flatten back out because all of this stuff is logarithmic. And so this is the equivalence point where the x-axis is the amount of sodium hydroxide added. And here's just kind of the same curve I drew here. Right, so that's a strong base with a strong acid. You can take a look at the reverse in your book as well as weak acids and bases. Also, you want to take a look at the calculations in example 14.21 and 14.22 on your own. I won't show them just because they're a little bit tedious and not too difficult. You just want to work through them so that you kind of understand how to do these calculations and whatnot. And so one question you might have is why does this color change occur? And so that's because we added something called an indicator. And an indicator is something that changes color according to the pH. So when it's at a certain pH, it's one color, and then beyond that pH, it's a different color. So you can have all kinds of different types of indicators that will indicate different pH ranges and have different colors. So if you're interested in whatever range, you just want to pick an indicator that's appropriate. The most common one used is phenolphthalein, and that's the one we're going to use in our lab. In acidic conditions, you can see it's white. And then in basic conditions, it turns pink, right? That's what you see in this picture up here. And so you just want to pick one depending on which zone you're interested in, right? If you're interested in studying something between the pH range of 2 to 4, maybe you'd pick this one up here and that kind of stuff, right? So pick one depending on range of interest. pH range of interest. And so another question you might have is why do these compounds change colors according to the pH? And that's a bit of a more complex question. Basically, upon the addition of acid or base, there's a change in the structure of the compound. So there's a reaction and then a change in the structure. And then that change in the structure of the compound causes a change in the color of the compound. So between the structure property relationship. If you take organic chemistry, you'll learn a lot more in depth about that, but unfortunately, that's kind of beyond the scope of this course. And then here's just how a titration curve looks for a weak acid. So in this case, we're titrating a solution of acetic acid with some sodium hydroxide, and you can see it's approximately the same. It's just that your solution starts off less acidic than it would be for a strong acid, right? Because it's a weaker acid, so it doesn't make the solution as acidic.